you know, and I was on an event earlier, and Kelsey Hightower was being interviewed, and he was talking about Kubernetes and how we're trying to simplify things, and and how does this actually work out? And he said something too. He's like, serverless databases are really cool, and I'm like, yeah, they are really cool. And through that conversation, I kind of realized something about that. And I think what's going on with serverless and serverless database, and what this talk is about is, we talk about Kubernetes, we talk about automation, we talk about efficiency, we talk about, all these amazing projects that are going on at the infrastructure layer. And often, I think developers don't think that they are cloud native because they have to think differently as well. I think they think about being cloud native as controlling infrastructure, but actually the way you architect your application as a developer is really ultimately, I feel, kind of one of those key things which makes you cloud native. Reinventing things to actually be cloud first, to take advantage of scale and resilience and all these great kind of promises that we all kind of know in this community, I think is one of those things that it's got to get into the head of developers, so that from the bottom of the stack all the way to the tips of the fingers and the mouse clicks of your users, we're cloud native up and down. And to me, I feel like serverless is kind of this wonderful combination of all these things, because if you don't architect to be serverless at the very beginning in your application, and you're just kind of using, say, Kubernetes to deploy a serverless service, right? And we'll show you a little bit of that. You may be only going halfway. And that's really what this talk is all about, okay? So I'm going to dive into this. Let me get over to my slides here. We will start in just a minute, and that is right now. First of all, my name is Jim Walker. I am Principal Product Evangelist at Cockroach Labs. Prior to this, I was at a company called CoreOS, early days of Kubernetes. I've been in data for a long time. I love data. Oh man, these are old slides. I had somebody doing this with me last time. I forgot to change my pronouns here, but I'm not two people. I'm just one for my pronouns. I am not an expert by any means. Software engineers that build databases are incredible. I do study them a lot, and I am curious about them, because ultimately I think some of the stuff that we're going to talk about in this conversation, I think this is the stuff that makes careers. I think that this is the stuff that, when we look back in time, 3 to 5 to 10 years from now, we're gonna be like, oh man, how did we not think like that? I think this is all very much emerging still. I don't think anything is fully kind of, like evangelized and known and everywhere. But I think it's all really cool stuff. And so hopefully this is at least entertaining and hopefully valuable to you all. If you have questions along the way, please do ask them. I'm sorry, but I don't have the chat anymore, but I'm always happy with, Lisa or anybody jumping in and asking me questions along the way if you have it. So we're going to talk a little bit about serverless. And, serverless is kind of one of these things that when I first heard it, I was doubtful, honestly. I don't see it. But now that I've been in this a little bit longer, I'm definitely a believer in it. And like to explain a concept, I think the best way that I've used to explain this to like salespeople, so they really get it, is always where I start, is if we take the term wireless and apply it to a phone. Well, back in the day when I grew up, we had phones like this. We hated the people who had zeros in their phone numbers because, it would take forever for us to dial them, right? But eventually we had these home phones that were wireless, and then we had these kind of bricks that were in our pockets and the Nokia ringtone. And today we have like these phones that, oh man, I don't even know. I don't even think I use this thing as a phone that much anymore. I mean, it's so complex, but this wireless concept has actually taken the phone and moved it all the way to something else. We can think about this the same way as we think about cars, right? Back in the day, I didn't have a car like this, but I know my brothers worked on cars like these in the 70s. You understood everything that was in there. And then we started to apply like servo motors and electrics and sensors and everything to the car. And in the middle, that's my car. That's what I understand, which is basically like bring it into the shop because I have no idea what's going on. And then on the right-hand side, I have no idea what this is, but this is a Google search for an electric car motor. So I don't have one, but I presume that's something like that. Ultimately, the car is still the car. We have changed the car. We have applied the principles of electric to the car to change it. And so when I think about serverless, we're going to apply the serverless principles to the database or to our application or to the data center, right? And when I think about, serverless computing, it's really about kind of a couple of different kind of core assets or core principles. Number one, well, the term is serverless, which means basically like I don't want to deal with servers. And by not dealing with servers, this also means like this thing should scale up and down, and it should be resilient, because dealing with scale and adding resilience, that's dealing with servers, right? And then if it's also there, I don't want to have to deal with downtime. It should be there. It should be available. It should be instant. There should be no interaction with an SRE to spin something up or get a VM moving or something. And then I think where serverless gets really interesting is really in this last bullet. And this is really becoming, where we become consumption based. And, I challenge all ISVs and anybody building software to think about your applications and how you can become consumption based. Because I think ultimately in most organizations, one of their biggest concerns is like, oh my God, what is my bill to the cloud provider? And how do I shrink that? Do I want to run an application on some instance and pay for the full compute when I'm only using like 20% of that? How do we do this? How do we make things multi-tenant? How do we rate things? How do we charge and only pay for what it is that we're actually consuming? And when I think about serverless, I think about these kind of 4 core concepts. Now, we've applied this. We're doing these things today, but I envision a future that's much further than any of this. We think about serverless compute. I love Google Cloud Run. Throw a container at it, and it spins the thing up and down. It's really cool. Talk about compute savings and stuff. I think that's a really amazing stuff. All the stuff going on with like serverless functions, like the Lambda stuff, the cloud functions, Netlify, the kind of event-driven functions where you just basically have this function. It's not on a server. It just gets invoked and it goes away. And I think that's amazing. I think it's architectural kind of an app development thing. And then finally, there's this kind of new platforms that are kind of coming about where it's, we're getting this like the full infrastructure, compute, and architecture is like all coming together so that we can actually do what I'm talking about. But I think even in the context of a serverless app development, we need to actually look inside our code to make it serverless. I'm going to demonstrate how we can use Kubernetes to deploy a serverless service, but I think you need to look inside at what you're doing to think about multi-tenancy, to think about how you split things apart so you have ephemeral compute separate from the static and the storage, right? Those things that are tied, right? And so this is the kind of stuff where it's not kind of left and right brain. It's not left or right brain. It's kind of left and right in terms of infrastructure and code, right? So when I think about the database, when I apply these principles of the database, there's also a couple of other things that are kind of tricky here. When we talk about resilience, a database, is that in a single region? Is it a single AZ, or are we going to fail across domains and regions? What are your failure domains? Thinking about that. What does it mean to have geographic scale? Because I tell you what, when you're dealing with data, there's no joke, the speed of light comes in. That's always a challenge. What am I wrapping transactions with like a 3-second pause or half a second pause because the database is really far away and I don't want a transaction timeout? That's not serverless. That's not thinking about it in the right way. Like understanding inside the software itself, how do you mitigate these sort of things? Because serverless to me is not just like single data center. Serverless should really be infrastructureless. It should be regionless. It should be load balancer-ish. It should be, like all load balancer less, I guess. All of these things, right? And so we think a lot about these things in the database today and kind of how these things work out. So like ultimately, how do we take the term serverless and apply it to the stuff that we already have? How do we make all this go away? And I think that's really what this talk is all about. So I talked a little bit about the serverless database stuff, but some of those other significant challenges we're going to talk about is like placing data close to users. What happens when I spin down compute and I still have storage issues? What about transactional latencies? We talked about, and I talked a little bit about infrastructureless. So, okay, so let's talk about the database, and we can think about this as really kind of any piece of software. So remember, let's get cloud native in our code, right? Less about cloud native in our infrastructure first. And if I think about, a database is really comprised of 3 layers. There's the language, which for me, it's SQL. For others, it's other languages. I always think in SQL. That's the way I learned. At the bottom, there's storage, and in between, there's this like SQL execution thing. So like when you select star where name equals this and join and blah blah, that execution thing actually becomes like a bunch of different kind of points of an execution. So that gets really complex. And so if I think about things, really that's it. And my friend Dan Goodman at Ultimate Tournament once said to me, he's like, Jim, a database is nothing other than a translation layer between a user and the storage. And I'm like, yeah, you're kind of right, man. That's really what it is. It's just basically that binding to actually store things, right? Now in Cockroach, which is a distributed database, this is a little bit different because we aren't going to do execution in one place. We're actually going to do this in multiple different places. Now that actually lends well to the serverless concept. And we're also going to replicate and distribute data. So we aren't going to actually just write data storage once and then synchronize to, disks in other places. No, when we write, we use something called distributed consensus. And we'll talk a little bit about RAF, because I think thinking through distributed systems and thinking through, how like distributed consensus works, or multi-version concurrency controls, and like some of these kind of advanced, distributed system type algorithms from a developer point of view, actually is what we need to think about if we're going to truly make something serverless at both the software and the infrastructure layer, right? So for when you think about this and say you have an app, what you want to do is really find the divide. And the divide is really those things that are ephemeral, those things that don't really need state, and if state goes away, it's fine, versus the things on the bottom, which actually you need to remain state. You need static kind of ties to that, right? And that's typically the storage layer. In Cockroach, we're storing things to disk in each pod, and I can use stateful sets to actually manage that. So if the thing goes away, I bring that persistent volume back. These sort of things, right? The storage class in Kubernetes, and so that needs to maintain the way it is. Yet all the stuff up top completely ephemeral. And understanding that divide and separating your application and the logic in your application between ephemeral versus kind of static, I think that's the trick to really thinking through from the software layer how these things work. And then you're going to use infrastructure to actually sort that out. So let's talk about storage. I'm going to go through this relatively quick, but storage in Cockroach really, when you think about a database, typically you're thinking like, oh man, I'm appending a row and I'm writing that to a database. Well, in Cockroach, we actually do something a little bit different. When we write things to disk, we actually have a database on top of a database. Like everything to everybody else, it just looks like a relational database. It's wire compatible with Postgres. Like you're writing selects and you have DDL and DML and you control the database. That's all great. But at the storage layer, we're actually storing data in a huge, massive KV store. We actually use something called Pebble, which is a derivative of something called Rocks. Get it? Rocks, Pebble. We rewrote Rocks and wrote it in Go and called it Pebble, right? But ultimately, this KV store allows us to do some really cool things. But we had to change it to actually make it multi-tenant, right? Because I'm going to have a lot of different data stored in this thing that's very, very static, right? And so if you think about data in this kind of KV, all the tables have a primary key. And within our storage here, what we're doing is the K in the KV is the table name, an index, the key itself, and then a column name. And then the value is the column value. The best way to show this is here. I'll give you an example. We're going to convert this SQL here to a KV store. So on the left-hand side, we have this table. It's called dogs. Primary key is ID, name, weight, just a real simple table. And on the right-hand side, this is what a table might look like. Now, underneath the covers in Cockroach, when we actually store this stuff, again, we're going to store this as this huge kind of monolithic, lexicographically sorted KV store. So we're going to take that first record, and it's going to be, okay, the table is dog. The key, the primary key is ID, which is 34. And at the value for name, we're going to write value Carl. At the value for weight, we're going to write 10.1. And we're just going to go down the line here. And right, so what we have now is this huge like sorted KV set, right? And so if I want to insert another value here and say the ID is, 83, we're going to know to actually insert those two rows in the KV store right there. Now that's really cool because what we can do is now basically create ranges of data. We're going to split this data up and store it within a cluster. And we'll come back to that. But right now we're basically sorting these things and we're just assuming there's one user. And if we have this huge monolithic thing, well, the table is dog and like the next table is say address, and that's all basically in order, right? Or maybe that was before this, right? In this huge KV store. What we did to make this serverless to actually make this layer multi-tenant is we actually appended a tenant key to the front of the key that we had before. We had dog. Right, so now I have a user, and so now all the records in this huge KV sorted set, all the users for one user are in one basic set of this stuff. And we're going to break that stuff down, and we're going to do auto sharding and all this stuff that I'll show you. But ultimately, all the user data for one person is here, all the user for the next is here, and on down the line, right? Because this is all sorted, right? So we've added this tenant. Now all this data actually belongs to that tenant, and that's how we actually can tie it to a particular person as well. That was the first thing we had to do when we started thinking at the storage layer, kind of how we were actually going to separate data, right? Because we're going to have one big thing. Now, up the stack in this execution distribution layer, right, we have this KV store. Now, how are we actually moving this data in the cluster? Well, actually, this huge monolithic sorted key space, we're actually dividing that into these kind of 512 megabit ranges. So, it's like we just have huge chunks, like these we call them ranges, right? It's just chunks of data. Think of them as shards, tablets. There's lots of different people in which we call these things. And 512 is really the way in which we optimize kind of movement of these things within a larger cluster, because we're going to write these things to disk, right? And so that's basically what we do. So what we've done is we have created shards, and we're going to automatically break these things down. Now, in an instance of Cockroach, depending on the size of your database, there'll be hundreds or millions of these ranges kind of floating around within a cluster, right? And so in order to find that data, well, we also had to create a structure, an index structure to actually find these things. So this is implemented very much like a B tree. So if I want to find a record for, say, Muddy, which was my dog, I need to go to the second range. So I'm going to find that within the cluster. And so the cluster has all these materials to find where data is, because we're going to separate this. We're going to spread this out across lots of different storage nodes, right? Now, we're using something in Cockroach called Raft. And Raft, if you aren't familiar with it, you should be if you're in distributed systems thinking through these things. In fact, etcd, which is a core part of Kubernetes, uses Raft. The etcd Raft implementation, I know a lot of stuff that we've done. We've contributed to upstream Raft for that. So it's used within etcd. But this is really what allows us to kind of atomic writes, right? So when I write something to the system, I'm going to make sure that that thing is going to be written and it's going to be right. And I'm going to be able to ensure that I get consistent reads across these things. And Raft is a distributed consensus algorithm. It's chatty, like there's stuff going on all the time. And really what you're doing is you're writing things in triplicate is what's going on, right? So basically a replica, a number of replicas is really what distributed consensus is all about. And you're going to have an odd number, 3, 5, 7, 9, right? So that when I write in distributed consensus, 2 of 3 of the nodes or the ranges have to actually commit that record before the third one acknowledges back, and I'm good because I have quorum, right? It's a way to get quorum. This way you aren't synchronizing data between, fully, synchronized like instances of a database underneath. No, you're actually writing it in triplicate, right? And so there's a special person or a special replica in this concept. It's a Raft leader. They coordinate all these writes. You are always sure that the Raft leader is up to date. What's really cool is if one of the Raft leader goes away, the Raft group understands that and says like, oh, wait, I only have 2 of us. We need to create a third one somewhere so you can actually survive. So Raft is actually pretty cool. And it also allows us to basically get this atomic replication. I'm not going to get too deep into that. But if you want to learn more about Raft, go check out this website. I've sent, I don't know, hundreds of people to this thing. But whoever built this, they just done such a great job. So the secretlivesofdata.com really has a great implementation of this. Now, I'm talking about this in the context of what we're doing in our database. Raft is actually applicable to lots of different things. And when we think about how we're coordinating things within a distributed system, because remember, this is up in the software layer of the applications we're building. If our applications are going to be cloud native, we have to start thinking in distributed, right? We think about the physical nature of data. We're going to be using Raft down below in etcd and Kubernetes and all these things. But distributed consensus is really what's going to allow us to get these kind of like authoritative rights and make sure data is correct within a distributed system. So I use this and talk about it in the context of what we're doing here at Cockroach, but actually pretty important overall. When we write data to disk, we're just basically writing it 3 times across 3 physical nodes. I write the second range, I write the third range. And what we've done, we just distributed this data so that if I lose a node, I still have 2 of 3. And I have this kind of distributed system, right? And Raft is really what's allowing us to do that within Cockroach, right? So, okay, so great. I talked a little bit about what we had to do in the software, like in our database. We actually had to change the way that we deploy Cockroach. And we're using Kubernetes to deliver a serverless database today. Today, look at like Cockroach works really, really well on Kubernetes. It is basically designed in the same kind of principles. It's really kind of was inspired by Spanner, and Spanner kind of being the internal database that Google had used, right? Cockroach really implements a very similar architecture. But when you deploy it, it's a node-based system. I have 3 nodes. They're working in combination to do these things. And I 4 nodes, 5 nodes, but it's one single cluster, one logical database. And I could deploy this across multiple regions. I could talk across multiple Kubernetes clusters, lots of different things, right? Lots of options there, right? And so what I deploy is what we've done is we said, let's separate out the storage from the ephemeral compute. So now I have a virtual cluster that just has these, what we're calling SQL pods. And down below, I have this huge shared repository, one cluster that's just only doing the storage and replication of data down below. And I can have lots of different clusters up top all accessing the same storage layer, each of them being completely, firewalled off because I added this multi-tenant action to the storage down below. So I have virtual cluster 1 just living on storage, cluster 2, 3. They can all basically live on this huge storage cluster. Now, there's nothing really kind of static in the top part of this. These are completely ephemeral. I just executing a query. I don't need anything other than to interact with storage, do these things, and return things back to the requesting application. So that's how we do that. So when we deploy, these things, we have, CockroachDB Serverless actually is doing this today. We could have, our storage and replication across 3 different zones, because if I lose one, I still have 2 copies, right? And I'm going to take our pods and I'm going to deploy those, my SQL pods, which are these, small instances of Cockroach running on a pod, all controlled by Kubernetes. 10 and 2 maybe is running AZ2. 10 and 3, we're going to spread those pods across 3 different zones. Maybe they have 4 or 5 because I have an increased amount of demand for that particular application. And we're just going to spread them out so that if we lose an AZ, we still have access to whatever it is that we need access to. Now, but how do we find each of these tenants? Well, in order to do this, in order to implement the serverless service that we did, not only did we have to do this, but we had to actually create this proxy so we can actually identify where things were within the cluster as well. So we're just communicating to the proxy. The proxy has a manifest. The manifest says, hey, tenant 1, those SQL pods are here, here, and here. And so the load balancer is just going through the proxy to route queries to any of the tenants, right? Any of the SQL pods for that particular tenant. That SQL pod can then interact with all the storage and replication layer down below to get that data, because it actually just knows where that is via what's going on, right? Just ask that layer for that information. It all coordinates and returns back from a cluster point of view. And so really that's kind of how we're mitigating kind of where and how these things are all living within the cluster itself, right? Now, we wouldn't be able to do this if the software itself wasn't distributed in its own nature, right? So that's where this kind of software layer, kind of cloud native stuff becomes really, really important. But this is how we're doing it underneath. Now, this has allowed us to build a serverless database for really anybody. You could go start up one right now, you check it out, and all this is going on underneath. Now, scale is interesting. In Cockroach, we just spin up a new node, point it at the cluster, you get this kind of, horizontal scale. It auto shards, it creates more ranges and all these different things. We can even scale to, multiple different regions and, lots of the AZs and clusters, right? There's all these things. Well, in a serverless database and in a serverless application, you're going to have to accommodate for, this elastic usage, both up and down, and with huge spikes or no spikes. And by the way, if it's consumption based, you're going to have to deal with scale so that you can spin, these SQL pods down to 0, because, well, I don't want to pay for things I'm not using, right? And we're doing all this via these kind of ephemeral SQL pods, right? And so what we built in Cockroach is an auto scaler. The auto scaler just sits there and looks at the pods. And this is, one of the benefits of using Kubernetes, understanding CPU usage on each pod over the last 5 minutes, and then also understanding like peak CPU usage within that pod. We're basically monitoring all that across the entire cluster, across all these pods. And really based on demand, we can scale things both up and down, right? If we need additional capacity, we go up. If load goes to 0, we just spin it all the way down. And so, what does that really look like? So here we are, steady state with tenant 1, right? We're going through the proxy. We're servicing, this load, which is up here on the left-hand side. This is our average kind of load for that particular tenant. It takes, 3 SQL pods to actually service that up. And what we do is in each AZ, we have these things called hot pods, right? And the hot pods are basically instances of Cockroach that simply have not been defined to a particular client, right? So remember I talked about this manifest within the proxy. Basically, these things are unassigned in that manifest, right? So nobody's going to use them until they get assigned to a particular tenant, right? And we just take that tenant thing, all right? So what we do is when load goes up, we can spin up, we can take one of these hot pods, assign it to a tenant, and make it move. Oh, I'm sorry, did somebody jump in? Sorry.
Oh yeah, no, Jim, there was a couple of questions that was a good time to ask. And there was a question about if it, does the scaling happen across cluster, and also is, especially with Kubernetes, how does CockroachDB scale across Kubernetes clusters?
Yeah, so scaling Kubernetes clusters is difficult. I remember way back in the day, there was like SIG-Fed, the Federation's special interest group. And man, it's so difficult to figure out all these things. I think getting a single control plane to manage these things, like what the team, like the Upbound team is doing with Crossplane, is really interesting from a management point of view. But really kind of federating resources and just really kind of trying to deploy, that's tough to do. For us, it's a little bit different because, as long as we can mitigate the network differences between clusters, which we do, like you use like an isovalent or a scupper or something like that to like mitigate across multiple different clusters, we can actually implement a single logical database across multiple Kubernetes clusters. So, in this case, you could have 3 Kubernetes clusters, one in AZ1, AZ2, AZ3, maybe a whole other region. And you're going to have one single logical database where you can ask any node within that database to find that, and it's going to find the data across those multiple clusters. So we actually federate at the, kind of above the Kubernetes layer. And this comes back to kind of one of these things, Lisa, like designing the software to be cloud native is different than using the infrastructure to be cloud native. Like the Google team and what they did is it's just truly amazing software engineering because they did think about it at that software layer. And that's where kind of Cockroach is really quite different. We aren't doing auto sharding. We aren't doing like, single AZ or a single region. No, we can actually do this really across any failure domain you could imagine.
Yeah, super cool. There was an earlier question also about how the joins work in the key value conversion, but you might have answered that or touched on it. I don't know if you have anything more.
Yeah. So Risha, great question. So how do joins work? So the KV conversion is just used as the storage side. That's like looking down into storage. KV is not used at the SQL layer. The database is just a completely distributed SQL execution model. Like we rebuilt the SQL execution engine. So we aren't using Postgres. We aren't using like the Postgres execution engine. We rebuilt that to be distributed. So think like MapReduce, right? Like the way MapReduce works, like push things down, does things in each region, and then brings it all back, right? And so we're basically doing the sort of same thing where we're mapping down to nodes and then reducing back to the top and performing the join and returning it back to whoever it is that's asking for it. So like the KV stuff is not exposed to anybody. It's really an implementation detail. I expose it here to help us understand kind of like how we had to make things multi-tenant to get this kind of shared storage layer mostly.
Okay, cool. And I'll let you keep going, but in the end, I'm going to talk to you about like what workloads are optimized for serverless, especially, and what our customers are doing, like what would be optimal. But keep going. Well,
let me just finish this auto scaling, Lisa, and then we can talk about that. But yeah, let's just hold on a second. I gotta I'm like single laptop here. So as we were talking, like the auto scaler. Okay, so there's an increased amount of workload. We just take one of these hot pods. We assign it to a user. Now I have more ephemeral compute to service more kind of transactions. This person is happy, right? Because the CPU load is now even across all these different things, right? I'm kind of great. And then basically this comes back to normal, volumes, and it comes back to this normal state, right? We're just managing these things over these kind of 5-minute increments in time to understand what that is. Well, sometimes basically our transaction levels go down to 0. And so the system and the serverless version of Cockroach is actually smart enough to say, hey, wait, man, there's nothing coming in. Spin this thing down to 0. Have no pods assigned to that particular user. And so now there's no consumption. And so there's no billing for this time for this particular user. However, say on Friday night, oh my God, somebody asked a query. I got to spin that thing back up. Again, we're going to take one of these hot pods. The proxy is going to get the query and say, wait a second, I don't have a SQL pod to actually route this to. I better go get a hot pod and start this thing right away. And it does. And so we're able to get that done pretty fast. I think a lot of work is done in this kind of wake up mode in serverless applications. How long does it take for you to actually wake things up? The hot pods thing, it helps a lot. Like these hot SQL pods, like that are just running in Kubernetes. Like I don't have to wait for the pod startup time, which can take a while in Kubernetes, right? And a while for us is, 50 milliseconds, right? 100 milliseconds, because, people can actually realize there's a delay in a query and something could go wrong. And right. So for us, ensuring data integrity is really important. So we work a lot on trying to get this kind of this startup, this wake up time to be really great. And I think that's one of those things about serverless you really got to think through. Now, behind all of this is basically an engine which is kind of, registering and understanding compute by tenant. And there's a whole other world of actually how we had to aggregate that information so we can charge people or not, and all these different things, right? And so, building what you want to do is one thing, right? In your own software, making that cloud native, deploying these things, and making it work in these contexts actually gets really interesting. So, like to me, ultimately, I think serverless really gets broken down into let people start instantly, eliminate the concept of operations. I don't want to manage the thing. I don't want to upgrade. I don't want to operate the database. I just want the thing to scale, and I don't want it to go away. Now, if we think about that in the context of our applications, those kind of 4 things, we'll start building some really interesting software out there. And I look forward to the next couple of years as people get their heads around these concepts. How do we actually build scale into an application? How do we build resilience into our applications, right? How do we deploy things or architect them so that we can do things like Kubernetes has rolling upgrades. That's really cool. Well, does your software accommodate for that? Or I do need some like complex operator to do so. And so these are the things that if you can actually do this in the software itself, it's going to allow your customers to just focus on what they want to do. And for us, that's a database. Like ultimately, I think a database should be nothing more than a SQL API in the cloud with like 7 or 8 endpoints around the planet. You just code against an endpoint and you never have to worry about any of this stuff. And I think that vision of like what applications need to be for devs and users, I think ultimately is kind of this world of serverless, or what I like to think of as kind of infrastructureless. So you can start a CockroachDB instance right now, a serverless instance. It's free. We do provide them for free. It's up to 5 gigabytes of storage, 250 million request units, which is basically an abstraction of the number of queries that you're running. And request units are interesting. We reserve enough so that you have enough for the rest of the month. It isn't like if you use everything one day, your app's just going to die. We're just going to reserve enough of that for you. And so, I think, Lisa, you were asking about, what is CockroachDB serverless good for? Was that one of the questions you wanted to ask as well?
That was, and we also have Bogdan's question. So let's go with Bogdan's question first. I'll put it on the screen. How is the restore handled on this distributed database?
So that's a really, really great question, Bogdan. And so outside of the context of serverless, and there's other things that are going on in the serverless mode. But if you just think about any distributed system, and you think about backup and restore for a distributed system, what if I'm going to do backup and restore across 5 different instances of something? What am I just going to run that through one instance and backup or restore that one instance? It doesn't make a whole lot of sense. What you want to be able to do is do distributed backup and restore. So each component in your distributed system is actually doing backup and restore, right? And now there takes a lot of coordination to actually make sure that backup has happened across, say 5 instances or whatever that is. But you want to do these things in a distributed fashion, right? It's the same thing for something like CDC. Like if you're using change logs, each component in the system needs to have its own change log and kind of emit its own change feed out so that you're doing kind of CDC in that way. We do that as well. So we think about these things in a distributed manner. Now, there's something that Cockroach does, which is pretty cool. We didn't touch on. We can actually tie data to a location. So like, all German records in a customer table live in Germany, and all UK records live in the UK. And here in Spain, they live in Valencia, down the road from me, I guess, or something, right? And so, that's kind of cool. And we can ensure that data is physically located next to that, on those machines that are in those locations. For us, what if you were doing a backup and you basically invalidated all that? Like, oh, the backup is now all going to Portugal for all those things. You've now like one of the benefits of Cockroach is like the compliance with data privacy or like some of these complex regulations is really cool. Like I can tie data to a place and the database is doing that. I don't have to do that in my application. For us, we had to make all that distributed. And so
and that seems like it's such a huge selling point, as every organization is trying to figure out where is our data, what that. So you sell it as pretty cool, and it's like you are going to solve all of your compliance headaches, your data headaches. Like if you use this, you'll know where the data is supposed to be.
Yeah, and Danielle, easy on your language there, pal. Right, like all of your compliance problems. Ooh,
okay.
What?
Yeah, there's a lot of compliance problems out there.
Super complex, and it is so complex across like every jurisdiction. And like, so are you going to allow developers to do this via best practices, or does that restriction and control belong in the infrastructure, which I think is the data? And I think let's put it next to the data. And like, it's one of those things interesting. One of the ways in which people use this too. There's 2 other ways in which people use this feature. Actually, Danielle, is kind of cool. Like, yeah, sure, there's this compliance thing, but like, what if I wanted to control egress across multiple clusters? Like I have this single logical database, but you know what? I know most of my users are hitting this cluster. I don't want to have to go across like 2 time zones and pay for the data to move and all these things. So like, can I start to control costs is another way? Well, confidentiality of servers, like think about different layers of clusters, Kubernetes clusters with different like confidentiality settings, because the security is different between them. Is certain data living on, like, there's lots of different ways. We call it geo-partitioning, and it's really like the geo is really like physical, and like, what is that physical location for you, and what does that mean? And so it's a pretty cool thing. But I mean, in the context of this question, backup restore is tough, man. And doing it in distributed nature is definitely something that, again, as we architect our software, thinking about that in the software itself, like being really distributed on those things. I love that question, Bogdan, because that's what we got to start thinking like as software developers. We got to think cloud native. We got to think distributed, not just like, hey, we're going to put this on a VM and whatever, containerize it, and like the Kubernetes people are going to deal with it. No, we got to think about this in software. I think it's a great question.
So a question also came in about just how to make sure the pods spin up quickly on demand. And this is obviously a Kubernetes audience. So when they're saying pods, I'm not sure, like maybe nodes, or maybe they mean the Kubernetes pods, but the question was how you make sure the pods spin up quickly on demand.
Yeah, so there's a lot of craziness going on. Again, this is where I'm going to fall back to just, I'm the marketing guy. I'm not an expert, but it's all good. There's a lot of what we do. I mean, basically, like, look at the proxy, the layer that was the proxy. Basically, it has a manifest. And if I need to spin up something really quick because something wasn't there, it just basically communicates with one of those pods and assigns a tenant to that. And now that SQL pod, which has an instance of Cockroach running it, is now assigned to that tenant. It needs to communicate to the other proxies that are in the other availability zones as well. So that takes a little bit of time. Is that 50 milliseconds? Is it 150? Right now, I think we're topped out about 120, 130, something like that, which is pretty fast, 130 milliseconds. But we want to get that to be instant. We want that to be under 50 milliseconds. So there's lots of optimizations that we're doing, Lisa, to actually get that to work. It's not an easy problem to solve, like especially when you're dealing with like millisecond concerns, because the database needs to be really super fast and instant. So that's kind of some of that stuff.
You got an applause to that one. I don't know if you can see the questions and the things.
I'm looking at them now.
Oh, okay. Well, there's this other one that, and this is kind of a leading question, but I didn't ask it, I promise, just about the companies that are using CockroachDB serverless. Yeah. And what is like, is compliance the bulk of the requirements, or what do you see some of the best use cases?
Yeah, so it's a great question. It's going to allow me to talk about two things. Number one, CockroachDB serverless today is beta. It like, you have it in a single region. We aren't doing the multi-region beauty yet. Like that coolness is coming very soon. Trust me. And that's a very difficult problem to solve, right? Because how do you auto place data and do lots of different things? There's some really cool software engineering going by the team right now. So serverless doesn't really do all this compliance stuff yet. Compliance is one of the things that people use Cockroach for. Ultimately, like, using something like Cockroach, think about like how Kubernetes like basically just automates a lot of stuff. Like everything in our prior conversation with the Fairwinds team about like, oh, we're taking stats, like optimize Goldilocks and like all that stuff that we're trying to kind of automate. We've done that to the database. In fact, honestly, Google did this. Google designed this, like 12, 15 years ago. We were inspired by that, and we too believe in automation. So how do I automate scales so I don't have to do manual sharding? How do I automate resilience so I'm guaranteed on and available all the time? Like, they're just huge, massive efficiencies, and if you want to scale a database across multiple regions, good luck doing it with a legacy database. The synchronization, those challenges are difficult. And so it's a database. If you want to ask me about workloads, it's all the workloads. Honestly, it's so funny. Salespeople ask me all the time, like, hey, how do people use a database? I'm like, for everything. Like, what, all of it.
When does your application not have some sort of state and data that needs to be stored?
Well, yeah, exactly. Right. And so
I think a website that can just go away after, close a browser.
I mean, I feel like the salesperson would understand how many times you open Excel in any day.
Nailed it. Thank you. Yeah, you should join
Yeah, and I think we are kind of running out of time for questions. Jim, do you have a wrap-up slide or?
No, that's it. We're at KubeCon this week. I'm here in beautiful Valencia. You can tell. Like, I don't usually have that outside my window, this like thing. But we're here in Valencia. If you want to see a demo, you want to check us out, you want to say hello, you want to give to a good cause. We're doing some really cool things in our booth. Funding, I think, women who code. What are the things that we're doing, Lisa? It's like,
sometimes we do Girls Who Code. This time we're doing Black Girls Code, Code 2040, Cancer Research Institute in memory of our dear friend Dan Cohn. And also, it's really super cool. And every company that's involved today is donating, every time you come to our virtual booth, $2 to the World Central Kitchen, which is already providing 300,000 meals a day to Ukraine. Wow. A day to Ukraine. And so all of the companies involved today are doing that. And when you visit our booth in person, there's a passport that you can get stamped and go around. So every company that you've seen today, go visit the booth, go get your passport stamped, and there'll be lots of cool things and also stuff donated to World Central Kitchen.
Lisa is just on message. I'm over here doing presentations and stuff all day. Like, I have no idea. I'm happy you're here.
Thank you. I'm glad I'm here too. And I'm also glad that you are here, that you were here. Thank you so much, Jim. That was awesome. Great amount of information. You can find Jim on our Slack channel if you join us on Community Slack, if you have extra questions, also in our forum. And also, James, do you have your Twitter? Sorry,
I think it's like the next slide or whatever.
Oh, just put it in the comments. So if you want to reach Jim on Twitter, it's not even on this.
That's not it. That's just my mug.
Yeah. It's like Jamesy, at Jamesy. So we'll put it in the chat, and then you can reach out to Jim directly. But really, really appreciate the time. Really appreciate you stopping by.